Hello student, I welcome you all in online lecture series. I am Dr.Ganesh Mogal, Assistant Professor, Department of Physics, KTHM College, Nasik. Today we are going to discuss error in computational from computational physics. So let's begin. In previous lecture, we discussed about the graphics in a C. Graphics in a C, different graphics command, then a different program, that is a program to draw line, circle, ellipse, rectangle, bar, arc. Also program to draw a concentric circle at the center of a screen. In previous lecture, we also discussed about the program to draw simple cubic structure and C program to draw Miller indices of 111 plane. Friends, in this lecture, we have to see what is error in computational, what is accuracy and precision, and what is a significant figure. After attending this lecture, student will be understand about error in a computational physics or error in a computation, then accuracy, precision and significant digit. Error, the difference between true value or standard result and approximate value or measured value is known as error, or simply we can say that error is difference between standard result and measured value. So there are different types of error. First is a inherent error. Inherent error also have two types. First is data error and second is a conversion error. Second type of error is a numerical error. Numerical error also have a different types. First is a rounded off error and second, in a rounded off error there are again two types. First is chopping and second is a systematic rounding. Okay, so these are the two types of rounded off error. The second type of a numerical error is a truncation error. We have to see all these error one by one. First is inherent error. Inherent error are error present in a data supplied. Okay, we know that there is a data supplied by computer. Okay, and therefore there is an inherent error. Okay, and there may be statement of problems. This error is also known as a input error. They are present in a statement of a problem, hence they are also known as a input error. Then throughout these error are out of control of machines. This error is not a control of machines, okay, or we can say that computer, and therefore this error cannot be reduced. But this error can be reduced by defining the proper problems more accurately. When we define the problem more accurately, then this inherent error can be reduced. Inherent error contains two components. First, data error. Okay, that is, it is due to the data. Okay, and the data supplied, okay, to the computer. Okay, so that error is a data error, and second is a conversion error. Data error, it is also known as a empirical error. And when we obtain data for problem by some experiment or some measuring technique, it has limited accuracy and precision. Accuracy means the closeness to the standard result. is the accuracy. Data error or the empirical error may be due to some limitation of our instrumentation, therefore may be unavoidable. Now, in computational physics, we use the instrument. Generally, we use the computer. Okay, and the computer has some limitation. Okay, and this error is unavoidable. Okay, when we have to avoid this error, we have to replace the our machine. Okay, through the error are out of control. For example, a physical measurement like a distance, voltage, or a time period cannot be exact. In a measurement, physical measurement like a distance, okay, distance, voltage, or a time period cannot be accurate. Okay, the time period can be measured by using simple pendulum. Okay, and measurement of a oscillation of a simple pendulum, the error can be introduced. There is no use in performing arithmetic operation. To save for decimal place, when the original data then slave are only correct to two decimal place. Now, conversion error. It is also known as a representation error. These errors are due to limitation of a computer to the store the data exactly. We know that a floating point representation retain only specific number of digit. Floating point number means the number which consists of a decimal point. Okay, and the floating point representation retain only a specified number of digit. The digit that are not retained constitute a round off error. We have seen that many number, for example 1 by 3, cannot be represented exactly in a given number of a decimal digit. In some case, the decimal number cannot be represented exactly in a binary form. For example, the decimal number 0.1 has non-terminal value like 0.0001100110 and so on. But the computer retain only specific value. Computer retain only specific value, and therefore this error is due to the limitation of a computer store the data exactly. When we have to represent the floating point number, that is a number which consists of a decimal point, then there are some limitation. Computer retain only specific value. Then numerical error. Numerical error are also known as procedural error. They are introduced during the process of implementing the numerical method. Okay, they are arise in a two form. First is a rounded off. We can rounded particular number or the number up to particular decimal point, and the second is a truncation error. Now we have to see what is the rounded off error. Rounding or taking place because of rounding the last significant digit to the nearest value. For example, 1 upon 6 is equal to 0.1666666. Okay, if a computer represent only 6 significant digit after the decimal point, then 6 digits should be rounded, or the sixth digit, 6 number digit should be rounded. Hence 1 upon 6 can be written as 0.166657. Okay, 6 digit. 6 number of digit is a rounded. Okay. We know that the significant digit is greater than the 5, then add 1 in that significant digit. If it is less than 5, then remain is it as it is. Okay, and therefore it is a 6. So add 1 in a 6, it becomes 7. So 1 upon 6 is equal to 0.166657. Okay, so this is a rounded off. Hence the rounding or will be error. That is the sigma 1 is equal to 0.166666 dash up to so on, minus 0.1667. Okay, and we get this rounded off error is about 0.0000, that is a 6 times 0, and after that 33333 up to so on. Okay, so this is a rounded off. Thus the process omitting superfluous digit and keeping only the desired number is called rounded off. Now rounding a number can be done in 2 ways. First is a chopping, okay, and second is a symmetric rounding. Now we have to see what is the chopping. In this method, extra digits are dropped. Okay, extra digits are dropped. In case of the rounded off, there are so many digits. Okay, and the computer cannot be store all these digits. Okay, and when we have to store the floating points variable, it is computer have some limitation, and therefore we does chopping. In this method, the extra digits are dropped. This is also known as truncating the number. Suppose we are using computer with a fixed word length, that is of a 4 digit, then the number 12.3496 will be stored only 12.34, and the number or digit 96 will be dropped or chopped. Okay, so this is a chopping for the computer with fixed word length of a 4 digit. Then systematic round off, symmetric round off. In this method, the last retained significant digit is rounded by 1. The first discard digit is greater than or equal to 5, then add 1 in last significant digit. If it is less than 5, then keep it as it is. Now, for example, the number 12.3496. Okay. Now, here the last we consider the word length is 4. Okay. So the computer store only 4 digits. Okay. So that the last significant digit is a 9. Okay. Last significant digit is a 9, which is greater than 5. Therefore, add 1 in second significant digit. Now 4 is a second significant digit, and when 1 is added in a second significant digit, it became 5. and we get value 12.35. So this is a symmetric round off. Very simple. When last significant digit is greater than or equal to 5, then add 1 in a second significant digit, that is digit before the last significant digit. If it is less than 5, keep it as it is. Then we have to see what is the truncation error. The truncation error are generated when required significant digits are considered and remaining are discarded. Only particular number of significant digits are considered and remaining are discarded. Okay, it is error resulting from truncation of the numerical process. For example, consider a value 1 upon 6. The 1 upon 6 can be represented at 0.166666 up to 6 digit. Only 6 digit after decimal points are considered, and remaining digit are chopped or truncated. Now error, it is equal to true value minus approximate value. True value is 0.166666 so on, minus 0.166660, and so that we get error 0.0000666. Okay, so this is the error. Hence error E is a true error. From above example, the truncation error obtained also has a finite significant digit. The truncation error are also occur in a series of expansion. If you consider a sine series, then the sine series can be written as x minus x cube divided by 3 factorial plus x raised to 5 divided by 5 factorial minus x raised to 7 divided by 7 factorial plus so on. Now there is an error. When we calculate the sine angle using above the series, we cannot use all the terms in the series for computation. We consider only some terms. Okay, some terms are omitted. Okay, we terminate the series after certain terms are calculated. The terms which are truncated introduce truncation error. Okay, due to this we omit some terms. Okay, or we neglect some terms, higher terms, and therefore some error is introduced, that is a truncation error. The truncation error can be reduced by using better numerical model which increase the number of arithmetic operation. In a computer program, we use various library function to compute, that is logarithmic, exponential, trigonometric function, and the hyperbolic function, and so on. In all these cases, we use a series to evaluate these functions. Therefore, it is important to know the truncation error generated by these functions. Okay, because we have to omit some terms in all these series. Okay, that is the exponential series, then there may be logarithmic function, sine series, cosine series. Okay, that is a trigonometric function and hyperbolic function. Now, so this is the flowchart which represent the all total error. Generally, in this lecture we discuss two error, that is inherent error and numerical error. But there is also modeling error and blender. Okay. The modeling error is due to the missing of information. Some information is missing and therefore there is a modeling error. And there is a blunder. Blunder is due to the human imperfection. Okay. So it is a human error. Okay. Human imperfection. Modeling error and blunder. Okay. Some information may be missing while writing the program, and then this is the modeling error. Okay. And some faults are introduced due to the human imperfection, and that is the blunder. But generally, we have to consider inherent error and numerical error. The inherent error have again two parts, that is a data error and conversion error. Data error is due to the measuring method, and conversion error is due to the computing machine. The computing machine also have some limitation. Okay. So when we have to store some floating point number or the number which consists of a decimal point, then we have to round it off. So rounded off is one of the numerical error. And in numerical method, there is truncation error can be introduced. Numerical method, that is when we have to write the trigonometric function, then hyperbolic function, logarithmic function, then we have to neglect some term, and therefore the truncation error is introduced, which is the one of the numerical error. Okay, so this is related to total error. Now, what is a significant digit? We know that when we have to measure some value, the digit has some significance in a measurement. Okay. But it do not necessarily denote a certainty. That is, the digit can be changed. The last digit can be changed. That is a significant digit. And the figure up to which we have to consider the significance, that is the significant figure. Okay. In a significant figure, we have to consider all leading zero, then trailing zeros, which are used to indicate the scale of the number or which represent the certainty in measurement. Now, suppose we write 2 upon 7 and it is 0.285714 and the value of pi is 3.14159. Then we say that this number contains 6 significant figures. Okay, 6 significant figure. That is, all the figure or all digit have some significance in a measurement, and therefore value of pi is consists of 6 digit, that is 3.14159, and all these digits have a significance, and therefore it have 6 significant figure. The concept of significant number is useful to indicate the accuracy of a numerical value. For example, if we consider x is equal to 12.30456 and only digit 12.304 are correct, then we may say that X has 5 significant digits and it is correct to only 3 decimal place. Okay, after decimal point. Okay, so significant figure is 5. In general, we when we say number is good to a 4 digit, it means that number has 4 significant figure. Okay, that is the 4 digit have significance in a measurement. Frequently, we come across the number with a large number of digit and it will be increased to cut them to a useful number of figures or digit. This process is a rounding off. Okay. Now, rules of a significant figure, very important. While writing the significant figure or while considering the significant figure, all these rules are very important. First is all non-zero digit are significant, or all non-zero digit have significance in a measurement and therefore consider in a significant figure. Second, all zero occurring between non-zero digit are significant. Okay, if the zeros are occurring in between two non-zero digit, this zero have significance in a measurement and therefore consider in a significant figure. Okay. The trailing zeros after decimal point are significant. Okay. If you consider, for example, 4.50, 0 after decimal point, this 0 have significance in a measurement and therefore consider in a significant figure. 67.0, this 0 also have significance in a measurement, therefore consider in a significant figure. 0.980, 0 after 8 also have significance in a measurement and therefore these three number have a significant figure, that is 3 or 3 significant digit. Zeros in between, 0 between the decimal point and proceeding a non-zero digit are also have significant. Example, 0.00043210. Okay. Now, the 0 after decimal point does not have significance in a measurement. But the 0 after non-zero digit have significance in a measurement. And therefore, 43210. This 0 each have significance in a measurement. Okay. And therefore, this number have significance in a measurement. Okay. Now 0.0043210, 0.04321. Okay. All these numbers have 4 significant digits. That is, the 4 digit have a significance in a measurement. Okay. Now, when the decimal point is not written, then trailing zeros are not considered in a significant figure. For example, 4,500. Now, in this number, there is no decimal point. Okay. Therefore, this 20 does not consider in a significant figure. Okay. This number can be represented as 45 into 10 raised to 2. Then it contains 2 significant digits. If we consider, but if number consider 4500.0, this have 4 significant digits because this number consists of a decimal point. Okay. So accuracy, the closeness to the calculated value or exact value is known as accuracy. Accuracy refers to the number of a significant digit in the value. For example, the number 12.368 is accurate to 5 significant figure. Precision. Precision is a number of a decimal position. Okay. For example, the number 12.368 has precision of a 0.001 into 10 raised to minus 3. This is the precision. Okay. Precision means repetitiveness of the value. Okay. This value may be or may not be accurate. Okay. That is, there may be precision. Okay. The value may be not accurate, but it may be highly precise. That is close to the accurate value. It is highly precise, but it may be not accurate. Okay. Now, consider this table. 5.4326. This is the exact value or true value. And if we take some reading and we get approximate value, that is 5.3382, 5.3381, 5.3383, 5.3382. Now, here the only last significant digit is a change, and therefore but our accurate value is 5.4326, so that this value is not accurate or less accurate, but the approximate value is repeated. Only last significant digit is a change, and therefore it is highly precise or having highly precision. Next example, 5.4326. Okay, this is our exact value or true value. And if we take some reading and we get some approximate value, that is 5.4325, 5.4327, 5.4324, 5.4328. Now, this value is close to the accurate value. Okay, so this is highly accurate, but it also precise. The approximate value is also precise. It is repeated, and therefore it is highly precision and highly accurate. Okay, if the value is, or we can say that the value is a change, then it is less precise. Okay, so this is related to accuracy and precision. So in this lecture we discuss error. Error means the difference between the standard result and measured value, or true value and approximate value. There are different types of error, that is inherent error. Okay, inherent error, then the numerical error, and there is also truncation errors. These are all are the errors. Then significant figure, the figure which have significance in a measurement but do not necessary to denote certainty. Last digit is the first significant digit. Okay. 0, 0 after decimal point does not have a significance in a measurement and therefore not considered in a significant figure. Here 0 in between two non-zero digits have a significance in a measurement and therefore considered in a significant figure. There are rules of a significant figure. Then accuracy, closeness to the standard result is known as accuracy. Then we also discuss about the procedure. Okay. And now you have some assignment. State two inputs error. Define the term error. Define the term accuracy and precision. What is chopping? What is truncation error? Now all these are short answer question. Now long answer type questions. Explain the term significant digit. What is its importance? What are the inherent error? How do they arise? And third question, distinguish between the round off error and truncation error. What are the round off error and how do truncation error occur? Give two example of it. Send this assignment on Google Classroom. In the next lecture, we have to see what is bisection method. Thank you.